Charge tapes lab. The purpose of this lab was to determine the amount of excess charge on a piece of tape. The charge tape was made by quickly pulling it off the base tape. So let's see. So we ripped this piece of tape quickly and it picked up some charge. We're going to call this the U tape. We then put the U tape right here. It was actually between two erasers. So the U tape was supported by two supports at either end, and the base tape was moved closer until the U tape started floating. So we pulled the base tape up. It also picked up some charge when we did this, and we moved it closer and closer until it started to have an effect on this upper U tape, until it started moving. This is the free body diagram. We got the two forces acting on our top tape, the force of gravity pulling it down, and we have the electric force, this repulsion force, pushing it up. The distance that we measured was 3 centimeters. These are the fundamental physics principles. So we made some assumptions, like this K right here equal to 9 times 10 to the 9th Newton meters squared per Coulomb squared. Our G over here is just 9.81 meters per second squared. And so what we assumed is whenever the top tape is not moving, but it's being held up by this bottom, by this repulsion force, that our electric force and our gravitational force are going to be equal to 0. So our Fe is going to equal Fg. And so when we set these two equal together and we're trying to solve for Q, this is the equation we get. We also assume that Q1 and Q2, these are the charges on the different pieces of tape, that they are going to be the same in magnitude because the tape is in similar length, so it's going to pick up about the same amount of charge. Alright, so these are some results that we got. The magnitude of the charge on the tape was 1.36 times 10 to the negative 9th coulombs. So what if the electrons had a positive charge and the protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? Well, really the only change would be it would then be attracted to negatively charged objects as opposed to being repelled by them. You basically just flip the signs on everything. So why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Well, then they start to lose that charge, so they become neutralized. And that brings us into the sources of error. One of the sources of error being that we did have to handle the tapes, so we have to assume that there was at least a little bit of charge that was lost. Another source of error would be the measured distance between the two pieces of the tape. It was very hard to get an accurate measurement without touching and further neutralizing the tape. We also didn't take the actual mass of the tape. We assumed it was 1 gram per meter, and we had each piece of tape was 19 centimeters. So we assumed that the mass of the tape was 1.9 times 10 to the negative 6 kilograms. So in conclusion, the charge that was calculated on tape was 1.365 times 10 to the negative 9 coulombs. And if we wanted to figure out the number of electrons that was transferred, well, we know that the charge of an electron is the 1.6 times 10 to the negative 19 coulombs. So we'll just take this number right here. So we'll divide our charge, divide this by this, and then that will give us the number of electrons.